Our next speaker then is going to be Ray Lee from Environmental Science Associates. And Ray has over 25 years of experience as an applications engineer and technical architect, 14 of them with ESA. As a technical architect, he serves as leader for a development team where he's responsible for software design, requirements gathering and definition, design, implementation, testing, maintenance of multi-tiered applications. That's a lot. With that, let me give it over to you, Ray.
As I'm Ray Lee, and as Lee said, I'm the lead developer for project team at in ESA that is responsible for developing the groundwater platform, groundwater accounting platform. So I'm just going to talk about that a little bit and just give you an intro of what the groundwater accounting platform does. Okay. So the groundwater accounting platform is an accessible open source water accounting platform that integrates data from a variety of sources and effectively communicates this information to support individual, local, regional, and state water management decisions. It's currently accessible at that URL, https groundwateraccounting.org. It's mainly used by, It's mainly used by landowners and water managers to track their groundwater and surface water usage relative to an allocation. It also provides flexibility and configuration options to be used by many agencies in a single user experience. The focus today of the platform is to build the California statewide version of it, but the configurable framework can be applied to agencies across the whole US. So here's a little bit of a platform history. Originally, it was built to help a local groundwater sustainability, GSA, a groundwater sustainability agency, implement a water accounting framework as part of the response to California's SGMA Act. It was originally sponsored by the Environmental Defense Fund, and it was built specifically for the Rosedale Rio Bravo Water Storage District in California's Central Valley. We basically conducted a bunch of public workshops between 2018 and 2020, and basically to figure out what we needed to prioritize and build. And then in 2021, the California Water Data Consortium joined the platform team. Together with EDF, they helped us secure some grant funding from the California Department of Water Resources and the U.S. Bureau of Reclamation, and allowed us to continue to grow the platform. That focus was on expanding the initial Rosedale platform to a version that can be used across the state of California and the U.S. We currently have 5 pilot water agencies who are currently using the platform. I think they're kind of listed over there. Okay, so part of the platform's objective is to basically build a framework that is open for all and to use and not tied to a single entity. So basically, we have an open source model, right? We leverage an open source approach to accomplish this. Some of the key highlights are kind of listed here. For the kind of technical folks here, we use the AGPL version 3 open source license. So basically, it allows anybody to kind of use it and enhance the source code. The only caveat is that they have to kind of bring us back their contributions, right? Firms like ESA may offer customization, training, onboarding, and hosting services, but not as an exclusive provider. And we want to emphasize that the source code is open, but not the user data. Okay, so here is kind of how we sort of integrate with OpenET. In the platform, there are basically 3 main roles. Third one is the platform administrator. It's kind of like me, who's kind of just more behind the scenes, making sure things get set up. There's the landowner and the operator, and they basically are, they use it to view and manage their water budgets for the parcels and one or more GSAs, right? And then there's also the water manager, and they're in charge of configuring accounting rules for their geography and administer these 2 water budgets. So here's a sample view of what like a landowner's view to their water budget looks like. Okay. So basically, they have access to water accounts, and water accounts are basically like collection of parcels or fields that they kind of manage, right? Basically, the water manager will set up the available water supply for each of the water accounts, like typically at an annual basis. And then a water supply can be any sorts of different type of water supply buckets, right? I'll talk about that a little bit more in a future slide. And then the usage piece of this, we basically bring in a variety of data sources, one being OpenET, others being like well meter data, and any other kind of external data sources, right? It really depends on what the agency wants to bring in, right? And then basically the landowners would then use this to kind of view their available water supply, relative to their usage. Oops, too much. So, as you can see here, we have a chart of like kind of 3 different data sets, right? Well, I think in this case it's like basically the ET precip, ET, just the ET effective data, and then like basically we did a post calculation to calculate consumptive use. Again, this kind of varies per agency, but basically these are typically tracked at the parcel scale, but it really depends on the policies of the agency, because they could allow water to be pooled across parcels with common owners or operators. So the budget, I kind of already talked about it. The budget on the previous page was a roll-up of supply and usage. And then here we're kind of showing more granular water level measurements. Mostly, we typically focus on monthly cadence. So at the end of the day, it really depends on what the agency wants to display, or kind of what they want to use to calculate and measure their data. And then we basically give them the tools to kind of compare and contrast these and make their own decisions on how they want to, what kind of policies they want to use, right? Again, we want to emphasize we are not the decider of the policies. Basically, we kind of provide the tools for them to kind of make those informed decisions. It's ultimately up to the respective agencies to kind of make those decisions. So this is an example of what it looks like in terms of their activity, right? We kind of took an approach of, think of it as like your checking account. Like we tried to kind of model that kind of a user experience. So basically, transactions get posted, in this case, like water supply in the beginning of the year, or like OpenET usage at a monthly basis. And in our conversations with Will, it seems like the data, at least the more recent data, it takes a couple months for it to kind of stabilize. So as we get new data on the next month, we post them as corrections, right? We don't actually overwrite existing data. So it's kind of sort of like a system of record kind of thing. So it's kind of like in your checking account, if you have a correction to some sort of deposit, you don't actually cancel out the deposit and re-enter it. We actually apply it as a correction. So that's kind of sort of the mock-up we try to go for. So it's a little bit more, so you can kind of see real time what's going on, like in a month-to-month basis. Okay, so this is more like a conceptual data model of how we kind of integrate with OpenET. Right now, we are using the raster API, specifically the time series metadata endpoints, and basically we pull them in. We typically make 2 calls, one for ET, one for precip, and I think all of them we use the ensemble model. For what reasons, I don't know. I don't remember. I think probably it's because maybe it sounds like it seems the most accurate. I don't know. Less room for error. But I think those decisions were made before my time, maybe. I don't know. And essentially, we pull them all in. And then there's a bunch of business rules that we apply per agency, and then they get posted to the ledger view that I just showed you, right? And any sort of other kind of other data besides OpenET, they kind of go through the same type of method, same type of method. Basically, they either would pull it in through a CSV upload or through some other data source, and it basically gets supplied with business rules as well. Okay, how we manage our OpenET integration. Typically, we have a monthly job that runs typically around the 8th of the month that basically just pulls in monthly data. We basically just fire off a series of monthly API calls per GSA. And then we slurp them in, and then we basically kind of apply our business rules, and then it gets put into the ledger. We also offer an ability for you to kind of do an ad hoc way of synchronization. So basically, that's what this view is. We basically kind of could just go on a month-to-month basis, just say, I want to sync this right now. We also have this concept of finalizing the data. Basically, it's like, I guess in this sense, it's more like we think that the OpenET data is no longer going to change. It's no longer churning, so there's no need for us to keep syncing. You know, it's mainly because we wanted to kind of minimize our API calls because we don't want to keep hitting, querying for data that's not going to change. That's how we currently use it. We are actually currently embarking on actually exporting the rasters themselves and doing our own processing, which was kind of timely since I just attended Nick's talk, and he's kind of doing the same thing. So it was kind of, pretty cool. But that's kind of like the next steps we're kind of working on in terms of how we're going to integrate OpenET data. This view here is kind of like an example of how we configure our water supply. So basically, the landowner's water budgets, they're made up of both the available supply and the estimated usage, right? So in the previous slides, we showed how the usage is brought into the platform from OpenET, but this is how we kind of manage the water supply. Typically, we define these for a GSA, and then I think probably once a year, we provide an allocation in terms of how much supply they're expected to have. And it could be broken down into types of water, right? There are other kind of views and screenshots that I could kind of go into, but in the interest of time, I decided not to kind of go all the way into that. But yeah, and that's it. Thank you for your time. I think my colleague Noah couldn't make it, so she sends her regards, but that's it.
Any questions for Ray?
I have one, if nobody volunteers. In your diagram, I saw that you had also flow meter or some meter data. Any comment on the comparison between the actual meter data and the OpenET data?
I think we provide the data flows for it. I don't know if we've actually gotten, I mean, it's really, GSAs would just kind of update those CSVs and upload them. In terms of the analyses of it, I personally haven't looked at the analyses, so I can't really answer your question in that regard, but the chart should, that previous screenshot that I showed you should allow you to interlay and kind of see like where their gaps or differences, right?
Thank you. Thank you for the presentation. I was wondering if you do any projection types of or predictive types of analysis, especially in the supply of water, or is it more of a allocation decided on an annual basis?
I think it's more of the latter, the allocation decided by a GSA.
You may have mentioned this, but if the groundwater extraction data are not available, what methods are there for estimating groundwater extractions from the other data?
Basically, it's just going to show up as unestimated for now, at least for the OpenET piece, right? unless a separate like meter data source was uploaded as well. Yeah.
Others? Maybe you've already covered this, but could you briefly address the distinction on that time series that you showed between the evapotranspiration and the consumptive use? You said the consumptive use is something that the agency sort of, is this like pumping data, or I wasn't
Yeah,
quite sure
so-
what this purple line is here.
So I think that's probably in this specific slide. I think this one is simply just evapotranspiration minus precip, right? But I think per agency, their formula for calculating consumptive use could be a lot more complicated than that. And I think as we're dealing with all the GSAs, we're figuring that out in terms of what they want their algorithm to be, right? But I think this is like the most simple case. So it's basically just evapo minus precip.
Okay, great. Thank you very much.